These diagrams will show us critically sampled analysis and synthesis filter bank in a direct implementation. So here we have our analysis filter bank. Here is our synthesis filter bank. So let's say in this example we are using 44.1 kilohertz of sampling rate. Here we will have our lowest frequency, and here we will have 44.1 hertz because we are going downsampling for 44.1 kilohertz using n equals to 1000, so that's a factor of 1000, and we go from 44.1 kilohertz to 41 hertz. That means that here we will have, with n equals to 1000, so this downsampling factor of 1000, we'll have 1000 subbands. So if our input signal x of n, for example, has 10,000 samples, and then it will be inserted in this filter bank, and we have 1000 subbands, and before downsampling, so we will have 1000 times 10,000, so we will have 10 million. That just before downsampling, but then when we apply downsampling, we will go back to 10,000 samples. So in this way we have no increase in data, so no increase in the number of samples. On the synthesis, now we also have in this case 1000 subbands, but then the 44.1 hertz sampling rate here is upsampled and goes back to 44.1 kilohertz, and then it's all added up, and here we have our h of n is our impulse response for the analysis filter. We have g of n, which is our impulse responses for our synthesis. They are added up, and then we end up with the reconstructed version of our input plus a delay. So here we see that we have the analysis, and there will be a convolution operation, and then we have downsampling, and in the synthesis we will have upsampling, then convolution with the synthesis impulse responses, then it's all added up, and we end up here, and you can see that we have all the equations that we've seen before. So the convolution for the downsampled convolution and the upsampled convolution. Now let's look more in detail now in downsampling and upsampling. So the operation of downsampling by a factor n describes the process of keeping every nth sample, discarding the rest. So if we have, this is our original signal, and then we will remove the in-between samples and we'll just keep the nth sample. So it's this one, this one, this one, this one, this one, and then this will be our downsampled version. On the other hand, upsampling is the operation that describes insertion of n-1 zeros between every sample of the input. So if we now had this as our input and we upsample by a factor of 2, for example, so we will insert 2 zeros between every sample. And in frequency, we see that we had this, but after upsampling, that will be some aliasing components, and it will repeat itself, and then we need to use a low-pass filter, for example, to fish back the original frequency, desired frequency we want. Let's take a look at the filter bank structure for the analysis filter bank in direct implementation. So we have here our x of n, we have our impulse responses, and we have our downsampling box, and we have n subbands. So for example, if we have n equals to 1024, so we have 1024 filters. Usually it's good to have power of 2 for efficient FFT implementation. If our Fs is equal to 44.1 kilohertz of sampling frequency, that means that the Nyquist frequency is half of this, so it's 22.05 kilohertz, and then we have that the Nyquist frequency divided by capital N, so the number of filters, and then we have that the Nyquist frequency is the sampling frequency divided by 2, and then we will have the sampling frequency divided by 2 divided by capital N, and we'll have a result of 21.5 Hertz. So if we have n filters and no downsamplers, then we would have n capital N times fs samples per second after filtering, and this is more than the input. So hence we use downsamplers. So with downsamplers, the number of samples stay constant. The downsampling factor is equals to the number of subbands, and this means critical sample. Of course, there can be filter banks that they're not critically sampled, but in this case here we are introducing the concept of critical sampling. That means that the downsampling factor is equal to the number of subbands. On the synthesis side, the synthesis filter bank, and we have here our upsampling box, our impulse responses, and a sum here. So upsample each subband by n to restore the original sampling rate. We apply passband filters to each subband signal, and then we'll add each subband signal to generate the output signal. So this is the structure, the filter bank structure for the synthesis filter bank.